So then we talk about the opposite of dilation, or not opposite of dilation, I'm sorry. It's not being able to do the operation, which we need to know how to do, which will refresh our memory here in a second. But can you tell me what the scale factor is? So if we look at scale factor, I know that scale factor tells me a couple of things. It tells me that if that scale factor is less than 1, it's called a reduction. That means it's going to get smaller. If the scale factor is greater than 1, that means it's an enlargement. I know it's going to get bigger. Okay. But when I'm finding, so let's break that down. If I give you this rule, so number 1, it says 1/4 x, comma 1/4 y. Well, if I change those to a decimal, 1/4 is the same thing as 0.25. Well, is that greater than 1 or less than 1? It's less than 1. So we call that a reduction. How do I know this is dilation? Well, remember what I told you yesterday. Dilation is multiplication. So because you have a number right in front of the variable, that's multiplication. Number 2 says 2x, comma 2y. Well, what are you multiplying by? You're multiplying by 2. Is 2 greater than 1 or less than 1? Well, it's greater than 1, so that means it's an enlargement. I know it's going to get larger. 3 over 2, when I divide that and change it to a decimal, that's 1.5. So not all fractions are necessarily less than 1, because 3 over 2 is actually 1.5. Since is that less than 1 or greater than 1? That's greater than 1, so we call that an enlargement. Number 4, 2 over 5, when I divide that out, is 0.4. So 0.4 is less than 1, so that's called a reduction. Number 5, if I just ask you if the scale factor is 5, is that less than 1 or greater than 1? That's greater than 1, so it's an enlargement. And then if the scale factor is 3/4, remember 3 divided by 4 is 0.75. 0.75 is less than 1, so that's a reduction. Okay, so you have to know the difference. But when I ask you to find the scale factor, let's look at number 7. When I have to find the scale factor, I have to find the coordinates first. So let's label the coordinates. I want to be very strategic though. Like I want to avoid decimals. So I don't want to use letter C because see how it's in the middle of a box. I don't want to use B because it's on the edge of a box, not the corner. So I'm going to use letter A. So can you tell me what the A's coordinates are? The new A is -3, 3. The old A is -2, 2. Now, I want to specify that A prime is the new one and A is the old one. Here's why it matters. Scale factor, to find scale factor, you have to do the new one over the old one. So if I type on my paper, the new one, which is -3, 3, goes over the old one, -2, 2. So then, look at it. It looks like one large fraction. -3 over -2. And that's what you type in your calculator just as a fraction, not division. -3 over -2 is +3 over 2. Same thing if I typed in the y's. 3 over 2 simplifies to 3 over 2. So the scale factor is 3 over 2. Well, let's do a quick check. Did my picture get smaller or bigger? Well, according to the new image, it did get bigger. And is my number bigger than 1? It is. So that's my answer. Now, how do we write the rule? Remember, dilation is multiplication. So 3 over 2x, comma 3 over 2y. That's how you write the rule to show multiplication. Look at number 8. So if I look at my points, any of these will work because they're all in the corners. So let's just say I choose letter C. I want to do the coordinates first. So the new C is 9, 12. The old C is 6, 8. So when I set this up, remember it's new over old. So the new is 9, 12, goes over 6, 8. And then I've just made two fractions, 9 over 6 and 12 over 8. When I type in both of those numbers, they simplify to 3 over 2 again. So ironically, the same numbers. But how do I know I did that correctly? Did my picture get smaller or bigger? Well, according to the prime, it did get bigger. So my number is bigger than 1. My answer is 3 over 2x, comma 3 over 2y, because dilation is multiplication. If I look at number 9, any of these points will work because they're all in the corners. So I'm just going to use the C's again so I don't have to worry about negatives and positives. The new C is 4, 2. The old c is 2, 1. So then if I put the new one over the old one that matters, I have made two fractions, 4 over 2 and 2 over 1. When I type that in my calculator, 4 over 2 and 2 over 1 both equal 2. Well, my question to you is, did my picture get smaller or bigger? It got bigger according to the prime. And since it got bigger, my number should be bigger than 1, so I know I'm on the right track. So how do you write it? 2x, comma 2y, because dilation is multiplication. Look at number 10. I'm sorry, none of these are like reduction, so that's my bad. Maybe on the back there will be. Number 10. So I pick a coordinate. Again, any of these would work because they're on the corner. So I'm just going to stick with the first quadrant, letter A. The new A is 4, 8. The old A is 2, 3. So I set it up new over old. When I type in, 4, 6. Wow, I did not do that right. 4, 6. And when I set up new over old, 4 over 2 and 6 over 3 all equal 2. How do I know I'm correct? It got bigger. So my answer is 2x, comma 2y, because dilation is multiplication. Number 11. Now I don't want to use, well, actually I can use, I'm going to show you what this one could do. I'm going to use S. Now, even though S is probably not ideal, none of these are on the corner, but that's probably, there's a reason. If I look at S, the new S looks like it would be a decimal, but it's actually between 14 and 16, which is 15, and it's on 18 there. Same thing with the old S. It looks like it would be a decimal, but it's between 4 and 6, so that's 5, 6. Okay, so then if I put new over old, so 15, 18 over 5, 6, and I type in 15 over 5 and 18 over 6, my scale factor is 3. How do I know I got it right? Because my picture got bigger. So how do I write it? 3x, comma 3y. So dilation is multiplication. Number 12. So you're going to see a question like this, like, Miss, I don't even see another picture. Like, where's the other shape? Sometimes all they give me is a single point. Do you see the B prime out here on the side? So they're forcing me to use B. I don't have A to choose. I don't have C to choose. So I'm going to have to use B. Well, the new B is 6, 2. The old B is 3, 1. So 6, 2 over 3, 1. 6 over 3, 2 over 1, both equal 2. And now this one's hard because, like, Miss, how do I know if it got bigger or smaller? It, I guess, more or less stretched. Like, it looked like it expanded. It went farther out. So if it got farther out, that means bigger. So my answer is correct. And how do we write it? 2x, comma 2y, because dilation is multiplication. We're almost there, guys, because we haven't even practiced reduction. All of them have been enlargement. So I'm sorry I didn't go back and forth here. But if I look at number 13, again, I just pick a letter. So I'm just going to stick to the first quadrant and choose M. The new M, notice, is the smaller shape. So that one is 1, 1. The old M is the bigger one, and that's 3, 3. So when I type in 1 over 3 and 1 over 3, it equals 1 over 3. Now, how do I know I'm correct? Because that number is smaller than 1. My shape did get smaller because of the primes. How do I write it? 1 over 3x, 1 over 3y, because dilation is multiplication. Same thing on 14. So if I look at 14, again, I'm just going to choose H or A because they're both in the first quadrant, and I like the first quadrant. So if I look at this, the new H is the smaller shape. So that one is 1, 3. The old H is the bigger one, and that's 2, 6. When I type in 1 over 2 and 3 over 6, they both equal 1/2. How do I know I'm correct? Is because my shape got smaller, my number should be less than 1. And how do we write it? 1/2 x, 1/2 y, and that is because dilation is multiplication. Number 15. Again, I can choose any of these because they're all in the first quadrant. So if I choose letter A, the new A is 2, 5. The old A is 4, 10. So when I type in 2 over 4 or 5 over 10, they both equal 1/2. How do I know I'm correct? Because my image got smaller, my number should be less than 1. How do I write it? 1/2 x, 1/2 y, which is multiplication.